and my talk is somehow related to what Amy started with the alternative proteins, but I will discuss the move from laboratory to the industrial scale of production of alternative proteins, mainly focusing on cell movement from the cell to the cultivated meat. So, okay. So the motivation to have alternative proteins from animals, okay, or replace animals, is the contribution of animals to, or rumen animals, to the climate production of CO2. Animals produce methane, and methane is 80 times more toxic than CO2. So if we can reduce the use of animals for food, then we may reduce about 10% of the CO2 production. And this is just, for me, it is a side effect. The main effect is that I'm vegetarian and I prefer not to use animals. So how we produce alternative proteins? There are three ways how to do that. First is producing from plant. Okay, take plant and or make the consistency in a way that it will look like a meat, and people will eat it, hopefully. Second is to use fermentation of bacteria or fungi to produce certain proteins, and then incorporate these proteins into food. And the last one is the one that is more challenging, is to take cells from an animal and grow the cells into a steak. So in the first technology, we have to select the right crops that the mixture of these crops will produce something that will look like or taste like meat or have the texture of meat. And here we have also to fit the proteins to the proteins of animals. The second option is, as I mentioned, to produce or to generate proteins by using yeast or algae or bacteria, and isolate these proteins and incorporate it into food. This is, of course, not so direct to a piece of meat, okay, or a steak, but it is very useful for making food like milk and similar products where they are based on a specific protein that is needed. So, as I said, the main challenge is to take cells and from an animal, let's say a cow, and these cells, to grow them outside of an animal, and eventually have a kind of meat. This can be either sheets of meat that later on we mix them together and prepare something that looks like a hamburger. Okay, it's not a steak exactly. And this is one way. And another way is to, or a more challenging way to make such a steak, is to incorporate several types of tissues in one growing piece of meat, where you need, of course, the muscle, you need some oily type, and the taste should be similar to a steak. And as I say, there is a company that is trying to do that, but this is the most challenging in the field of taking a cell and grow it into cultivated meat. So the field of growing a cell into a piece of meat is actually started from basic research on tissue engineering. What we see in the left side, where tissue engineering, the concept of tissue engineering is to grow outside of the body a piece of tissue, and then use this piece of tissue and implemented or incorporated or fuse it into the body where it is needed. For example, if a patient is missing an ear due to a car accident, then may manufacture the ear from the same cells of the same patient and take this ear and stick it where the missing ear is there. And this is the challenge. Okay? Other challenges are preparing an artificial liver and the artificial internal organs that are functioning and producing what the body needs to be done. But this is a big challenge because you can make everything perfect outside of the body or on cell culture, but when you implement it into a patient, then in most cases, even today, there is no success in the field of tissue engineering. Fortunately, the field of protein production, alternative protein came in, and then the people from the field of tissue engineering, including myself, switched into the production of cultivated meat, because the halfway of growing tissue outside of the body or in tissue culture, this was achieved already. So just taking it and moving it into cultivated meat, but the challenges are significant because for medicine, the cost is less of an issue. But for food, it is indeed an issue. Just to know that a piece of steak, okay, that companies are giving only to presidents or prime ministers to taste, okay, each bite probably costs $2,000. Okay? And so we are a long way to have a cultivated meat in the market. So we started with tissue engineering. Then we have to move into food engineering, because to make a food, it's not just to make a piece of something. Someone has to eat it and to feel it and to taste it and to have it as part of the culture or part of a food that is tasty. And then if we solve this, then we have to produce in large quantity. Okay, for the medical field, you need probably 100 ears per year for the entire world. But a piece of meat, you need significant amount of tons per year. So the growing of tissue outside of the body, this is known, this is done already for many years in culture. And the way how it is done is cells do not grow in a two-dimensional way. This is only the skin. The skin can grow. And this actually was done many years ago, even 40 years ago. Skin tissue was grown, and actually it was a company that used to produce skin for people that were burned. But still, it was not that effective, so this company doesn't exist anymore. But the way how it is done to make other tissues is you need a scaffold, where the scaffold is a piece of plastic or a sponge that needs to be degraded as the growing tissue or growing cells propagate into this scaffold. So the scaffold starts for the food industry. It starts from soybean proteins, and then the cells are grown onto this scaffold, and eventually what we get is a combination of cells that are integrated within the scaffold, and this is actually the food that you are eating. So when you are eating cultivated meat, it still contains the sponge that the cells are growing on. Okay, and then so we passed already the basic science on it, and now we have to move from a small scale to a large scale. Here we have to select a certain type of cell, whatever we decided. It can be a chicken, although chicken is not an issue for the environment. The main issue is cows and animals that rumen and produce the methane, as I said. Then we have to have a big vat where we load the cells. The cells start to propagate, and then we add a scaffold. Scaffold can be a small or micron-size particles that we add in, and then the cells stick to this micron-size particles and propagate there. So what we are generating here is a micro amount of or microbeads of meat. Then we integrate them into an hamburger or something like this. So this is the second challenge, okay, to move from a small scale to a large scale. And actually, we don't have such instrumentation because we never needed in the world to produce cells or to grow cells to the amount that we need for cultivated meat. And this is another challenge that we are facing. Then we have this kind of meat, okay, or pieces of meat, or sheets of meat, and how we take these sheets of meat and make them into a product. So if we go to the right side, we take the 3D printing. So we take these micron size particles that are pieces of meat and print them into a kind of a steak where we can prepare different types of tissues and then mix them together by the 3D printing. Actually, there is an Israeli company that is doing that now, or taking in the middle, what you see, taking the sheets of these tissues and stick them together so they get a feeling of a piece of meat. Okay. So if we move to another alternative protein, is producing milk from fermentation. And this is an Israeli company that already is selling their product. What they do, they produce milk, contains about 40 different components. But 39 of them, you can add them into milk, but one component, which is the protein casein, you have to produce it in large amount because this is the main component that gives the feel of the milk. And this is produced by this company, by a fungi that is producing this protein, and this protein became the main component. Actually, this company moved from Israel to, I think, Holland, okay, because in Israel they didn't get an approval for distributing this milk, and in Europe they are probably more flexible, so they moved to company there, and I think that they are making hundred thousands of liters of this milk, and it is, I'm not sure if they started already to distribute it, but this is one of the objectives. Another issue that is more relevant to the kosher people, or the people that are using kosher meat or kosher food, and the halal, and even the Christian people that are not eating meat during 1 month in a year, so it might be of interest. And the question is this meat that we are making from a cell, it is a meat, it is vegetarian, it is what? Okay, and this is a question, because if you solve the question, Jews may eat a pork, okay? Because you can take a cell, you make a pork, and then you eat it, and even the halal people may eat it. So this is an issue that is still open, but since the industry is very dependent on this answer, okay, so the Israeli rabbinic chief rabbi already decided that this is a non-meat, but you cannot use it to eat pork, okay? So it is something in between, okay, because it's too complicated to decide, okay, that you can eat it. Okay, so if we look at what's going on in Israel now with the cultivated meat, We have many companies that just started in the past 5 years. The most successful one are from the universities. 2 from the Technion. The 2 from the Technion, the Aleph Farm, and the other one, I can't remember the name. Both of them started from scientists that worked heavily in the tissue engineering. Okay, one of them even came from MIT with knowledge of tissue engineering, and she switched into this, but she still continues in the tissue engineering, but to see a product, probably she will see a product more from these companies than from tissue engineering. There is a big investment by the government to promote this field, because the government feels that, food is an area that we should invest, and since we have the knowledge, and many people are knowledgeable and are willing to expand on it. So we attract investments from the United States and other countries to promote this area. And as I said, why this is growing in Israel, because we have a strong academia in this field, the entrepreneurship. So any professor at the university is not looking only to publish in Nature, but also how to make a patent and an investment. And this is probably the reason that is propagating this field in Israel. So if we look at the number of companies, all of them started about 5 years ago. And we have in all 3 fields, we have cultivated meat. There are few companies because this is the most complicated field, but more companies are in the food based on plants, because you don't need the regulation for that is much less than the regulation for cell-based food, because this requires some like an FDA approval. And okay, I just, yesterday morning, I was waking up and I saw this from Forbes, and they try to kill this field. And what they say, okay, this, the perception of the people will be an issue here. And this reminds me the 40 years ago when the companies in the United States started to prepare crops from genetic engineering plants. And then the community said, oh, we cannot do that. And then the companies actually were not successful in having this product into the market. And this is an issue, because if you put in the perception of people that it is not good, it is causing cancer, okay, it doesn't matter if it is true or not, okay? But the FDA has to put his stamp on this technology, and I'm happy that the FDA already approved one product, and many other countries are moving into this direction, and hopefully the first issue is not an issue. Second issue is always an issue, patents and companies that are fighting. If there is a success, okay, patents matter. If there is no success, no matter how many patents you have, okay? So this is an issue. And then the issue of does this save the world? Yes or no? This is business. Business can do good to the world, but the main purpose of a business is to make money. Okay. And if I can summarize about this field, it is the cultivated meat is saving 90%. Of land, because you can do everything in one big building, and you don't need the farms. Less water, because cows are drinking water for a period of time, and not all the water is consumed properly. The less air pollution, this is of course. So from all of these parameters, there is a justification to continue and develop cultivated meat. Thank you very much.